Hello everybody and welcome to this video, and in this video what I'm going to do is that I'll make you familiar with the anomaly detection. So in this series of anomaly detection technique, what I'm going to do is I'll bring you up anomaly detection algorithms like k-nearest neighbors, okay, so that kind of thing. So in this video what I'm going to do, I'll give an introduction of anomaly detection. And I will ask you to continue with a series of anomaly detection, and this series will be in the playlist of end-to-end course, machine learning course playlist. So without this time, let's get into it. So before going into that, I will ask you to subscribe this YouTube channels and press the notification bell so that you can get the videos updates. So let's start with this video. So first of all, let's take an example. Here we have a data set x1, x2, x3 and all the way down to the xm, and here m is the number of training samples. Again, I'm recapitulating that, okay? And after that, let's say we have an aircraft engine features, and we have given two features, x1 and x2. In x1 we have heat generated, which is a feature, and x2 we have a vibration intensity, and there will be a lot of features. So we are just looking for aircraft engine features, so I found two features, heat generated and the vibration intensity. So we have plotted that. In the y-axis, x2 we have plotted vibration, and in x1 we have plotted heat, means x1, okay? And what we will do is that let's say our new training examples X test, we have given a new training example, let's say this one, and if it is here, then this would be okay, or not anomalous, and if we have an outlier which is here, and this is anomalous, because we'll talk about the density estimates in just a second, because it does not uphold our kind of threshold. Here it is greater than, or it is smaller than or equals to, we'll talk about the density estimation just in a second. So it is anomalous and it is okay, or we can say not anomalous, because it's something kind of outlier, and we can say that this is anomalous and this is okay. Okay, so this example is very easy. So now we have talked about the threshold, how we can assume that this is anomalous and this is not anomalous. For that, we have a density estimation technique. For that, let's say we define a model P of X. Okay, so here is my model P of X that tells us, and we have given a new probability, we have given a new training feature or a training examples that tells us the probability whether the example is not anomalous. In case of logistic regression, we just take the threshold at, if it is greater than 0.5, then we will take it has a cancer, or it is not greater, then we'll take it doesn't have the cancer, that kind of thing. And in this way we also deal with that. Okay, so if our probability is greater than or equals to, let's say, the epsilon, and here we usually denote this as the epsilon, and this is the hyperparameter which we have to tune. Okay, so this is my hyperparameter, and we usually call it an epsilon, and this is also, we can call it a threshold in simple terms, so that if our probability is greater than this, then we will consider that as okay, and if it are non-anomalous, and if it is P of X, our probability of our new training example or exact example, if it is smaller than epsilon, again this is an epsilon, if it is smaller than our epsilon, what we'll do, we will simply take it as a anomalous, that this example is anomalous. So let's say this we have a red color here. We have taken a red color, and yeah, so let's say this is my x. Okay, so p of x equals to p of x, let's say it is smaller than, sorry, greater than or equals to our epsilon. Let's say epsilon is 0.5. Okay, so we have tuned it, and if it is greater than this, this is not anomalous. Okay, or not anomalous. Okay, and let's say our outlier, we have it again, outlier, just something like this. So this one would be the anomalous, because our probability is lesser than our epsilon. Again, I'm recapitulating that in anomaly detection, we set epsilon, which is our threshold, and what we do, we just take out a threshold and we compare that. If it is greater than this, then we'll take this, and if it is smaller than this, then we'll take this. Something like that, and I've just shown you. If you haven't understand, I will ask you to please rewind this video and take a look at that. Okay, so again, I'm recapitulating that what we do, we define a model or a function which is p of x, and we set the epsilon, and epsilon is a hyperparameter, and what we do, we check if it is greater than or equals to epsilon, then it is okay or non-anomalous, and if it is smaller than our epsilon, what we'll do, we'll take this as an anomalous, just like I've shown you here. Okay, so till now we have dealt with this. Now, as this is an introduction video, I'm not going to go deep dive into math. In the next video, I'll bring up Gaussian distribution. Again, this is very important for moving further and making projects. And in this series, I'll be making different projects. As I'm not going to code that, maybe I'll be giving the Jupyter notebook in the description down box below. Not in this video, after making the mathematics formulation for any kind of project. So what we'll do, we'll make a mathematics formulation of the kind of any project, let's say document classification, that kind of mathematical formulation, and then I will ask you to implement that in whenever library you want. You just only have to understand the math behind the model. Okay, so what I'm going to do in the next couple of videos is that I'll make you familiar with the Gaussian distribution, and then we'll start picking off the project. Okay, so there are some example of anomaly detection. So here we have a fraud detection, and the first one is a fraud detection. Again, we set xi, again we set epsilon. Okay, so this is some kind of thing, and epsilon is our hyperparameter. Okay, we will talk about the parameter and a hyperparameter, the difference, because for the case of simplicity, the hyperparameter is that which we have to tune ourselves. As we'll go deep dive into the parameters in deep learning course. Okay, so now in this, I'm going to give you, and the hyperparameter is the parameter which are added and we have to tune it. Okay, and it is also used in manufacturing and a lot more. We will take a look at a project called document classification, classification, and I think this would be, I will be the mathematical formulation, of document classification. Okay, of document classification, and then we will, I think so, I'll building a recommender systems. See, I'm not going to make the code, but I will give you my Jupyter notebook where I coded that, so you can take a look at that. So I will give you the mathematical formulation, the theory part, and then you have to take a look at that. Mathematical again formulation. Okay, and I will give you the Jupyter notebook, and this two projects that we are going to do in anomaly detection. Okay, so I think that's it for this video, and from the couple of videos I'll bring in Gaussian distribution, as they are also very important part in statistics and also in our project of becoming the system. And you can also probably put your kind of these projects on your resume or get a profile, as I think that this course, I think it that this now if you have come up with this course and you are going to apply for the jobs, you can simply apply for machine learning engineer jobs, or I think you're an expert in machine learning. Okay, so if you're following up this course, so I think that's it for this video, and I hope that we'll be catching up to the next video. Till then, bye bye.